Hello everyone, Human Hard Drive here. If you remember a while ago, I did a video about this thing here. This is the Arduino Ethernet shield. I picked one of these up and I've been playing around with it. Well, very little bit, but now if you've been reading my blog, you know we're coming to the end of the Arduino tutorials, but I still want to do some stuff with shields and libraries, so that's what we're doing today. And so we're going to start doing some stuff with the Arduino Ethernet shield. Today what we're going to be building is a little device which will let you monitor the network latency of your home network. It's really good. I've actually been having a problem with my home network lately, and it's a pain to have to run to my router and back when I can just have a little thing I can look at to see how bad the latency is when this is directly connected to the router. So that's what we're going to be hooking up. So what are we going to be using for this? Well, obviously we're going to be using the Arduino Ethernet shield. An Arduino Uno. We're going to be using this. I used this in the simple SPI communication video. This is, of course, the 74HC164, which is a shift register. We're going to be using 5 LEDs and one of these. This is, if I hold it up a little closer to the camera, this is a resistor ladder. What it is it's actually 5 resistors in one tiny package. So all the resistors are connected to one single, well, it's actually this pin here, so that you can connect this to ground, and we'll be using this to hook all the LEDs to ground. This is a 330 ohm resistor ladder, and it saves space on the board. Speaking of which, you're probably also going to need a breadboard, which I have here. And one more thing. Obviously, because we're going to be using breadboard, it's always a good idea to have some jumpers lying around. Buy these in bulk. I have easily 100 of these. You'll lose them, or you'll have a bunch of projects. It's a good idea to have a bunch of these lying around. So let's start hooking this up. I'm going to start with the breadboard. Just going to go ahead and rotate this around so it's properly socketed. There we go. And the Ethernet shield goes on top. Now, the Ethernet shield has this little header here, and that connects to this header here. This is the ICSP, the in-circuit serial programmer, which is used to program the chip itself. If you're programming it in the Arduino IDE, you're not going to use this, but the Arduino Ethernet shield relies on that SPI communication to communicate with the Arduino. It also uses that same bus to communicate with the micro SD card, which they have broken out here. So that's that. Now what we're going to do is we're going to put in the... There we go. Oh, that's not seated properly. We're going to put in the chip. I'm going to put this right at the top. It's not as... Come on. Bend the pins a bit. And... having a wee bit of trouble. There we are. Alright, so that's seated. Remember, the notch of the chip always points, that indicates that on this side is pin 1 and this is the last pin. Now let's hook up some jumpers. I'm going to be using the power rails in this. The power rails are these two things on the side of the breadboard. There's one for power and one for ground. So I'm going to take the 5 volt from the Arduino Ethernet shield. I'll zoom in a little bit more. There we go. So VN ground 5 volts. Take that and connect it here, and then I'll connect ground to the rail opposite it. Now, on some breadboards, the power rail won't be connected all the way down. It'll disconnect halfway. That's not true in this breadboard. But for longer breadboards, you might have to add a jumper halfway through to make sure that the power goes all the way down. Okay, so that's that. Let's go ahead and start hooking up the chip. Let's. Normally, it's a good idea when you're doing something like this to have a color convention. I don't sort my jumpers as well as I probably should, so I'm kind of ignoring that convention. So we're going to hook up power. Power is pin 14, which is right here, and that'll be connected to that, to the positive power rail, and then ground is pin 7, which is this pin here. And then that gets connected to the negative power rail down there. So now the chip is powered. Let's go ahead and hook up some of the data lines. First thing we have to hook up is the data in. Now this is a shift register, so if you remember, it has two means of it requires two lines from the Arduino to put data onto the chip. One of which is the clock line. The clock line is pin 8. And we're going to make that pin 6 on the Arduino. And the other one is the data in line, and that is pin 1 here, and we're going to make that pin 7 on the Arduino. Now, this chip has an AND gate on the data in. So in order to make sure that all the data we pass to it goes to the chip, I'm going to connect that second data line to 5 volts so that it's always, there we go, so that it's always true. And that's the data lines connected to the Arduino. Now let's go ahead and hook up the LEDs. Now on resistor ladders, it might be a little hard to see because my camera is refusing to focus, but there is a little line here which indicates which the common pin is. It's where all the resistors are tied to. That's the pin we're going to connect to ground for the LEDs. So that's going to go right here. There we go. Then I'll connect the bottom pin to ground. Come on, plug in the, there we go. Okay. Now let's hook up the LEDs. I've got 5 red LEDs here. It's always a good idea to have a lot of LEDs. You never know when you're going to need them. And I'm just going to hook those up. Remember that the two ways to tell which way to hook up an LED. One way is the shorter leg is generally the negative. I say generally because I'll forget to cut these, so one might actually be longer than the other when it's not supposed to be. But the surefire way to tell is that there is a little notch here. It's flat on this side, and again round on this side. The flat side goes to ground. So there we go. Come on. Get in the breadboard. There we go. And let's just hook up all these LEDs. There we go, that one hooked up. Come on. There we go, that's 4. Trying to keep these in line as possible, but the breadboard seems to be fighting me. And then the last LED here. There we go. That one went in nice and easy. Don't know why the others didn't, but okay. Oh, there we go. That seems to work. Make sure that none of the LEDs are, none of the wires or their leads touch, because you don't want to short. And check. Always remember to check both sides. Okay, now we'll hook the LEDs up to the shift register. So the top LED I'm going to connect to pin 3. Wow, getting a little crowded up here. I'm going to connect to pin 3 on the chip. That is the first parallel output. Push that out of the way. Then the second LED is connected to pin 4. There we go, make sure I can see pin 4 on the chip. Third LED is connected to pin 5. The fourth is going to be connected to, there we go, make sure it stays in focus. Fourth LED is connected to pin 6. Which is right here, one above ground. And then the last LED is connected to pin 10, because pin 7 on the chip is ground. So pin 7, 8, 9, 10. Okay. These outputs on the chip that I've connected the LEDs to are labeled Q0 through Q4, 4. So 0, 1, 2, 3, 4. Those are the values we have to write when we're doing the SPI communication. So we want to remember that. There's one more pin I have to hook up. Almost forgot. And that is the reset pin on the chip. And that is connected to pin 9. It's active low, which means in order to make sure that the chip never resets, it should be connected to high or 5 volts. And there we go. So that is how it's hooked up. So now that we've got this all laid out, let's go ahead and look at the code. Okay, so the first thing you should do when starting a new project is go online and see if anyone's done something similar to what you're trying to accomplish. So I've got the Arduino IDE open, and if I go under their examples and under the Ethernet tab, there's something called Web Client. And Web Client is pretty much what we're trying to use. What this does is it goes out to a website, in this case google.com, and then it pulls in data like your browser would, except instead of creating all the text and images, it just gives you all of the HTML code that corresponds to that website. So what you should do is go through this and figure out what it is you need and what it is you don't need. So to start, I got some includes here. Probably going to need those. MAC address. If you don't know what it is, generally not a good idea to change it. So we're just going to let this be. The server, the website it's going to go out to. I'm going to leave this at google.com. You can change it to whatever you want. This is what we're going to use to time how long the message takes from when it's sent from the Arduino out to the server and for data to come back. That's what we're going to use as our judge for latency. IP address for the Ethernet shield, I'm going to leave that as it is. That's fine. Some init stuff. Probably don't want to mess with it. Okay, here we're getting into some meatier stuff. Client.connect server.80. So it's trying to connect to the server on port 80. I know from doing some stuff that port 80 is the HTTP port. We're going to talk more about some of the requests that get sent in later videos, but for now, just leave that. This get. So what it's doing is it's doing a search on Google for the keyword Arduino. I just want to go out to google.com, so I'm going to get rid of that. So it's just a simple get HTTP 1.1 command. Again, we'll explain what that means later. This stuff, leave. I'll explain it later. Okay, client.available. So it's printing out all the HTML code. I'm going to take this. I'm not going to tweak it just yet. Let's start simple. So we're going to do a pound define, and we're going to define the pins we need. So the clock we defined was pin 7, and we're going to pound define the data pin, which is pin 7. I might have missed that. Clock is 6, data is 7. There we go. Okay. So let's do some cleanup. Because we're going to be doing multiple requests, we're going to want to take some of these chunks of code and put them into separate functions so that they're easier to modify at a later date. So let's start with void connect to server. Gotta move my mouse. And what we're going to do is we're just going to take this beginning chunk of code, and I'm going to copy it. Now I'm actually going to cut it, and I'm going to paste it back here. So this is just the code that it's going to use to get to connect to the server, to the Google server. And now let's take another look. So I'll just replace that with connect to server so that it still works. Then let's look at the loop. This seems kind of important, and this seems kind of important. So let's take this whole thing. We'll cut it out of the loop, and we'll say this is void read info from server. Let's get rid of this comment. We don't need it. Okay, if client.available. This was handled by the constant looping, so we should put this inside its own loop. So while what? Down here it says if not client.connected. So there is some client.connected method we can access, which will say if the Ethernet shield is still connected to the server. So while client.connected. Oh, there we go. So while the client is still connected to the server, it's going to check to see if there is data available. How do I know the client's going to disconnect? Because there's this little bit of HTML code here, or HTTP request code that says connection close. So it's going to close the connection at some point. Okay, I'm gonna comment that because that's just gonna fill our serial monitor with a bunch of just garbage we don't really need. This is fine, and I'm gonna get rid of this while true because we don't want it to just sit there. And that looks pretty good. Alright. So now what? Well, oh wait, where was I? Client.stop. Alright, that looks good. So let's start with writing what's going to be in the loop. So the first thing we're going to say is, there we go. We did a connect to server, so now we're going to have to read info from server. Info from server. Then once we read the info from the server, we're going to wait. Before we do that, we're going to say long start time. We're going to do some timing stuff, so millis. So this defines the time at which, actually let me explain. I'm going to put this delay in, a delay of 10 seconds, 1, 2, 3. There we go, okay. So this is what's going to happen. It's going to connect to the server, and then it's going to read info from the server. That's just to make sure that we can actually connect to the server, and we can monitor that from the serial monitor. Then I'm going to put in a delay of 10 seconds, and I'm going to figure out what time we've started this. So we're starting a new cycle. So we're connecting to the server again, and we know what time we start. And when we finally come back from this function, oh, move my mouse, millis minus start time. This will tell us how much time has elapsed. So we know what time we started, start time, and we know the current time, millis. So that tells us how much time it has elapsed. That's the latency. That's how long it took to go to the server, submit this request, and come back. Okay. And then it's done that, and then it'll go back, it'll read all the info from the server, and then once it's done reading from the server, it will delay 10 seconds and then do this again. Now there is some stuff we have to deal with. First thing we should deal with is, well, big thing we have to deal with is the timeout issue. While client.connected. If we send data out, but no data comes back, it's still going to think we're connected, and it's just going to sit here and spin through this, never knowing when to leave. So we're going to have to institute some timeout. So what we're going to say is int start time again. This is a local variable, so it won't interfere with this bit up here. So while client.connected, or millis, keep putting my mouse in the way, millis minus start time is less than 1,000. So we're going to put in a timeout of 1,000 milliseconds. And every time we receive something from the server, we're going to reset the start time so that this stays below 1,000. So that's easy enough. So that takes care of the timeout issue. The next thing we're going to deal with is how to output data to the little LEDs we have. So that's going to be writing code to interact with the shift register. So we're going to create a function void output latency. And this is going to take an argument int value. And this is where we're going to do a little bit of math. We're going to create a variable, and we're going to define it as a byte data out. I'm going to start it at 0. For int I equals 0, I is less than value, I plus plus. So we're going to create a simple for loop. And in that for loop, we're going to say data out equals data out left shift 1 bit plus 1. This is a bit of binary math, and let me explain how this works. Okay, so here's your calculator. If you have Windows 7, I don't think this was in Vista, but in Windows 7, they have a programmer tab for the calculator. So we have a variable data out, and we want to make sure that the LEDs are lit up in whole LED arrangement. So we don't want we don't want 2 LEDs to come on and one that's off in the middle, meaning something like this. So you get 2 LEDs on, which are represented by a 1, and 1 is off in the middle, represented by a 0. We don't want that. So data out starts as 0. If we left shift 1, it stays at 0, and then we add 1. So the first LED is on. Now if we do that again, left shift 1, add 1. Now 2 LEDs are on. You do that again, left shift 1, add 1. 3 LEDs are on. And we do that until we reach the value. And then what we say is shift out. Shift out takes 4 arguments. This is the SPI command we used in the simple SPI communication tutorial. So the first one is the data pin, the second is the clock pin. The next one is the data order. I'm going to send that out MSB first. And then the data we want to send out, and that's data out. And so that outputs the latency. Now all we have to do is implement that function. So here we're just going to say output latency. How much are we going to output? Because this is going to be somewhere in the range from, if your internet connection's good, anywhere from 0 to 500. That's the window I want to define. 0 to 500. 500 is really bad, 0 is really good. Now there's a function called map. Map, technically speaking, is linear interpolation. You give it the endpoints of a line, and then you can feed it any point in between those two values, and it will tell you where that data is on the line. So what we're going to do is we're going to map millis minus start time. So that's the latency. That's the value we're going to map. That's going to go from 0 to 500. Those are the 2 endpoints of my line. And I want you to map that data from 5 to 0. So from 0 to 500. So if my data lies between 0 and 500, it's going to say it's somewhere from 5 to 0. Now, this is in order from 5 is bigger than 0. Normally, I would have put 0 to 5. I put 5 to 0 because a latency value of 0 is really good. So I want all 5 LEDs to light up. 5 LEDs on is good. If it's at 500, I want it to output 0, meaning my internet connection is really bad. So I have a good visual representation of my network latency. So the order you put it in matches with the order this is put in. Now, I could have reversed 500 and 0 and left this as 0 and 5, but this makes more sense. Well, at least to me. Might not make as much sense to you. Change it if you will. And so that's it. So let's compile it, make sure we didn't make any errors, any missing left or right parentheses or semicolons. Looks good. So let's upload that and see what it does. Okay, so what I've got here, I've hooked up the Ethernet connection. It's got a power supply. The Ethernet connection is right now running to my laptop, which is sharing its internet connection. Couple notes. I did have to clean up some of my wiring. Some of the connections weren't great, but everything is still connected as it was. And in the code, I forgot one thing. That was to define pins for the clock and data as output. That will be in the final version of the code. You just put that into the setup. My bad, kind of forgot that. But here we go. So I'm going to go ahead and turn off the overhead so that this looks a little, so that you can see the LEDs. And now I'm going to open up the serial monitor, which through the magic of editing, you can see. And I'm going to enable internet access to it. That's the wrong internet access. There we go. So now it's shared. So the little LEDs here means it's communicating. So on the serial monitor, we should see momentarily that it says connecting, connected. That's the first loop. That means it was able to go out to Google for the first time and get data back. Everything's good. Now it's disconnecting. We're going to wait 10 seconds, which you can tweak. That's that delay. And then it says connecting, connected. And it took, that 89 is the 89 milliseconds we figured out is how long it took for it to go out and get data back. So that's 89 milliseconds, which maps to a full value. 94, again, maps to a full value. So the numbers are fairly consistent as long as your internet doesn't change too much. Again, 94, it's pretty stable. But let's go ahead and get rid of its internet connection to see how it responds. So there we go. I've gotten rid of its internet connection, so you can see the LEDs stop communicating. Now it's going to say connecting, so it's going to try and connect. And it took that 1,000 millisecond timeout kicked in. So it took 1,820 milliseconds for it to realize it's not going to get data back, which maps to a value of 0 on the LEDs. So nothing works. So none of the lights come on. And I'm going to just go ahead and re-enable it. There we go. So it's re-enabled. So when it says connecting again, there we go. You can see LEDs and everything just comes back on. So it's pretty immediate. So that is it. So with the Arduino Ethernet shield, a couple LEDs, and a 74HC164 shift register, you can make a pretty simple visualization of network latency. So I'm Human Hard Drive. Thanks for watching.